On March 18, 1925, a funnel descended from a thunderstorm in eastern Missouri, and over the next 3.5 hours, 695 people would perish along the tornado's path, marking it as one of the deadliest weather events in American history. During March, Twister Talk will present a series of shows marking the 100th anniversary of this tragic event. We'll take a look at the day itself and discuss recent research detailing how this unfolded and other tornadoes that also occurred that same day. We'll also talk with author Angela Mason, whose book, Death Rides the Sky, chronicles what occurred that March afternoon from those who survived the tornado and the impact felt that day in their own words. That's Twister Talk with Gary, Sue, and Brandon on Podbean. And don't forget to check out our Facebook page.
Twister Talk with Gary, Sue, and Brandon starts now.
Tornado's crossing the road right in front of us. It's tearing something apart right now. Big power flash. Shoot, I think a semi got flipped. Are you okay? Hey, there's big rail coming. We gotta go, sir. Hang in the cut.
Gary, we're in Newcastle right now, and north of us, thing is still on the ground. There's lots of debris in the air right now. Lots.
You need to be below ground shelter.
I hate Oklahoma.
You always wonder about that. I was one of those guys that, oh no, the guy in the truck is flipping us off. The truck was flipped over.
Yeah, there's really a lot of questions about our opener, including, the lady from Oklahoma, which is a great mystery to me. How is she doing? We want to know this.
Yeah, we'd like to know, but like I said, I think, like last time we said, if we asked her, she'd probably, I'm not talking.
It's post-traumatic stress syndrome.
It's Twister Talk. I'm Gary.
I'm Sue.
I'm Brandon.
There's Brandon. He's there. You're in the weather bunker, right?
The weather bunker.
Yeah, I closed the hatch here and sealed the airlock right before we came on the air.
Oh, God. Is Dick Cheney with you?
Yeah.
If he is, I ain't seen him.
Yeah, probably better that you don't. Anyway, we're going to continue with our month-long reporting and looking back at the Tri-State Tornado of 1925, March 18th, the exact date. A tornado that basically is, I guess in some ways, a lot of urban legend around it. And in the way, the tornado was here that did this, did that, and everything else. But like we've talked about, it's for many years, it's been the forgotten storm. And I think the 100-year anniversary of the actual event occurring has kind of woke people back up to a little bit. I've seen some of the responses we've got online have said, we'd forgotten about this. Or one person, I never even heard of this. When did this happen?
It's kind of astounding that the most powerful and frightful tornado in recorded history people have never heard of.
Yeah, that's really strange.
Why are you listening to our program? Well, thank goodness you are, because we're going to tell you about it.
That's right. We're going to talk about the Tri-State Tornado. On this episode of Twister Talk, we're going to talk about the weather situation that helped spawn this storm. And also, as we go through that, we'll be talking about the updated technology or the updated weather things we use today as we go through that help them forecast or get a better idea of what happened. Chuck Doswell and friends, Chuck has since passed recently. They were working on a book back in the 90s about this, and really disappointed they never got published, because I would have loved to read that.
I'm hoping that the manuscript is out there and it may yet be resurrected in some form.
I know some of the manuscript did show up in that 45, 50-page document that the American Meteorological Society put out, and some of that's in there, but and there's some good information there. But this was a unique situation, basically, and we'll talk about it in a minute, of what led up to it and how this all came together. Now, springtime, you get thunderstorms and tornadoes and all kinds of weather.
As we're taping this, we're looking at the possibility of a big outbreak in a couple of days, so it's actually pretty normal.
Yeah, pretty normal. But the fact of the location of the supercell that formed and everything else made what we call, unfortunately, remember the movie The Perfect Storm? This was the perfect tornado storm. And so, Brandon, I'm going to let you start jumping in about, we're going to talk about the weather synopsis, how it all came together. So, Brandon, I give you the microphone. Go from there, buddy.
All right. So, looking at the meteorological synopsis here. So, what we start off with is an extratropical cyclone that basically set the synoptic or weather stage for the entire outbreak, that was centered over northwestern Montana as of 7 a.m. Central Time on March 17th. Now, meanwhile, we have a diffuse area of surface low pressure that's centered right over Denver, Colorado, in association with a Lee pressure trough. Now we have occluded fronts that are extended all the way from Hudson Bay up in northeastern Canada, southwestward into the northern plain states, and right into that Lee Trough around Denver. All right, so that synoptic cyclone moves south-southeastward across the mountain states into eastern Colorado. Now, at the same time, we have a warm front that is stretched along the Gulf Coast, and of course, it's separating warm, moist air from cool, showery weather with some areas of fog that extend all the way from Texas into the Carolinas. So we then have a well-mixed early season continental tropical air mass located over West Texas and northern New Mexico. Then a well-mixed early season continental tropical air mass existed over West Texas and northern New Mexico at the time. Now, to the east of this hot, dry air, we have buoyant maritime tropical air that's floating up from the Gulf of Mexico. Simultaneously, a mid to upper level shortwave trough likely approached the northwest coast of the U.S. and proceeded to move rapidly through the persistent ridge that was then digging southeastward across the Great Basin and central Rocky Mountains and emerging in the plains over Colorado. This, of course, initiated a Colorado low cyclogenesis. So this is where we're going to start to have some of the storms build up. Now, at 7 a.m. Central Standard Time on March 18th, the surface low pressure area, which was reading approximately 29.6 inches, moved to far northeastern Oklahoma while the warm front shot north into the circulation, where the front then extended eastward. Now, we had a maritime polar cold front that was draped southwestward across East Texas with a dry line forming directly to the south of the low, and we've talked about dry lines before. So that open shortwave was continuing to approach from the northwest, and an apparent outflow boundary moved just to the south of the warm front over northeastern Arkansas and northwestern Tennessee. Now, at the same time, we had several weak pressure troughs that were traversing that cool sector over the north-central U.S. Now, this is where surface temperatures in the warm sector near the dry line and the warm front ranged from 60 to 70 degrees Fahrenheit, and we're talking dew points of 55 to 65 degrees Fahrenheit, with even higher values the further south you went, and of course increasing over time as that deepening low pressure area continued to suck warm, moist air up from the Gulf. This resulted in unstable air and lower cloud bases, which of course is favorable to tornado formation. From the southeastern Kansas to Kentucky and Indiana, we had early morning showers and thunderstorms north of that low and the warm front, which were cooling and stabilizing that air. Now, this did a couple of things. First, it retarded the northward advancement of that front, and it also led to a much sharper contrast in temperatures from north to south. So now that differential between the warm, moist, unstable air south of the front and the cool, dry, more stable air north of the front is even more stark. Now, these zones are also associated with tornadic storms. So ahead of the surface dry line, which are not terribly common as far east as the Mississippi River, an apparent dry punch of air aloft served to further increase instability. Now, concurrently, meaning at the same time, we had a capping inversion that was likely suppressing storms throughout that warm sector. We've talked about what a cap is before. So that leaves the tri-state supercell undisturbed by nearby convection. We've discussed it on and off on the show that if you have a cluster of supercells within a given area, if one of them becomes tornadic, a lot of times the others don't, and that may be due to the fact that that one tornadic cell is kind of sucking all the oxygen out of the room, so to speak. By 12 p.m. Central Time, the deepening surface low was centered over south-central Missouri. The shortwave axis was moving easterly and was oriented over eastern Oklahoma, and the dry line was rapidly advancing eastward directly south of the low as the warm front, situated due east of the low, slowly started shifting northward. Morning cloud cover had cleared out by midday across much of the tri-state tornado's eventual path. This means a pronounced pressure trough extended northeast of the low and signaled its future track as a prefrontal trough formed southeast of the low ahead of the dry line. So it's already kind of setting up and, as we now know, indicating what track that storm would eventually take. A bulge in the dry line may also have been forming slightly south of the low, and southerly to southeasterly surface winds were increasing with time throughout the warm sector. So as the day goes on, those surface winds, they're starting to kick up a little bit. The tri-state supercell formed in a highly favorable area just ahead of the triple point. That's the spot where the cold front, the warm front, and the dry line all meet. The supercell initiated very near the surface low and then moved east-northeastward, much faster than the low. So much so that the storm gradually deviated east of the low's track.
All right, so there we go. And just real quickly, a point to make, and then Sue will continue in a moment. But basically, very rarely do we get dry lines east of the Mississippi. We had that in the 1974 super outbreak. A dry line, yes, in Indiana and Ohio actually made it that far east. It doesn't happen very often. When it does, though, that can give you a warning that major severe weather is going to be happening and breaking out. And so, Sue, of course, that's what happened there. The supercell initiated near the triple point with the low pressure, the dry line, the warm front, and cold front all together, and started growing and going. And because of the way the atmosphere was set up, nothing was around it, so it had everything to themselves.
No, it was. As I was listening to Brandon talk, I was thinking it's almost like you're loading a gun.
Yeah.
And then the trigger gets pulled, and all hell breaks loose.
And the trigger get pulled, and Sue will take what happens as we roll into the afternoon here.
By 2 p.m., and again, this is Central Standard Time, the low was centered slightly south-southwest of St. Louis as the tri-state supercell drifted towards the Mississippi River. Other storms in the warm sector that were not very close to the tri-state supercell were initiating around 3 p.m. And we'll be talking a little bit about some of those storms later, at least about as much as is known about them, which isn't enough. Around 4 p.m. Central Standard Time, the low central pressure dropped to around 29.5, centered over south-central Illinois as the supercell was moving into Indiana. Of course, by this time, it had already dropped a tornado.
Right.
The tri-state tornado was already underway by this time because it did drop in Missouri and then crossed the Mississippi River and on into Illinois and then into Indiana. It points out that the pressure is not particularly low compared to many other outbreak setups, and I was thinking that also as I read this, because 29.5 doesn't seem terrifically low, but the pressure gradient was strong, which induced strong gradient winds and significant advection in the warm sector. There was also a strong low-level jet just in place, just above the surface, as the winds veered with height, resulting in low-level curvature and long hodographs. We're going to have to do a show about hodographs sometimes.
Yes, we've talked about a little bit, but we need to go more detail.
Yeah, very strong wind shear.
Is that room on the Enterprise where you could make anything appear?
I don't think so. Maybe close, though. Strong wind shear thus existed, with pronounced directional shear likely in the vicinity of the warm front. And that made this storm not only powerful, it also pushed it along at a very high speed.
Right.
Theoretical hodographs returned estimated storm relative environmental helicity values of around 340 meters squared in the vicinity of the tri-state supercell track, which is extremely strong. And again, I think we'll be talking about helicity some more in the future. Strong thunderstorms by now were scattered throughout the warm sector, and a line of severe thunderstorms was occurring near the dry line. The tri-state supercell by this time was still discrete and isolated and was not too far from Cairo, Illinois. And incidentally, I'm kind of confused about that because I've always heard that it's pronounced Cairo, but I keep hearing people call it Cairo, so I don't know.
Yeah,
I have always thought it was Cairo because that's
same here.
How it appears to be spelled.
But I've also had people.
Well, that is how it's spelled, definitely.
Definitely had people though. Another part, even through Illinois, I've mentioned is the other.
I think in Illinois it's called Cairo, but whatever it's called, the tri-state tornado was in that vicinity.
Yep.
Now, according to the National Weather Service, and obviously Chuck Doswell and his team took a new look at this, there is no known photograph or film of the tri-state tornado. It was frequently described by witnesses as, quote, an amorphous rolling fog, unquote, or, quote, boiling clouds on the ground, unquote. And in fact, we were talking before we started taping, and the three of us kind of have come to the conclusion that possibly what people were seeing wasn't the tornado, it was the mesocyclone, and the mesocyclone was on the ground.
Right. Yeah, very possible. It would be similar to what happened in Birmingham. The mesocyclone wasn't on the ground, it was very close.
Yeah. And because they couldn't see the tornado, I mean, farm people are weather-wise. They
Right.
have to be. They saw this thing, and they literally had no clue what was coming at them. So they were struck by this tornado basically with little to no warning. The condensation funnel was also reportedly wrapped in dust and debris, which likely obscured it and made it less recognizable. The parent supercell apparently transitioned, and there's some controversy about this,
Right.
to a high precipitation variety by the time it struck West Frankfurt, which that was actually when the tornado was at its height and
Right.
caused the most damage and the most casualties, unfortunately, meaning the tornado was not readily visible as it approached, as it was often shrouded in heavy rain and hail. The very strong tornado at times exhibited an unusual appearance due partially to its size and the probable low cloud base of its parent thunderstorm. The tornado was often accompanied by extreme downburst winds throughout the entirety of its course. The accompanying downburst periodically increased the width of the damage path from the overall average of 3/4 of a mile, varying from 1 to 3 miles wide at times, which just boggles.
Yeah, this was an extremely powerful and deadly storm.
Yeah.
And we talk about that. And but, Brandon, over the years, we look some of the modern meteorological sciences we throw in today. And so, again, now we look at today's weather forecasting tools. And the people working on researching the weather and the basics behind the tri-state tornado and everything that caused that formation gathered information over the years. I mean, weather maps and anything they could find in maybe in archives about what was happening that day weather-wise, and they've run it through computers and simulation models. And there's been some questions over the years about certain aspects of the tornado, and Brandon's going to touch on those right now.
Right. So there has long been uncertainty as to whether the original reports of a 219-mile path over 3.5 hours was the result of a single continuous tornado or multiple independently tracking tornadoes belonging to a tornado family. Now, because of the scarcity of verifiable meteorological data from the time, and of course the apparent absence of any record of a tornado having approached this path length and duration in the years since, a lot of doubts have been raised about the possibility of the conclusion that a single tornado was responsible. To date, we do not have any definitive conclusion, and a complete understanding of what occurred is something that remains elusive. So modern meteorological theory regarding tornado and supercell morphology and dynamics would suggest that a single tornado lasting for such a duration is extremely improbable. We have several other historical accounts of very long track tornadoes, for example, that have subsequently been determined to be the product of tornado families. Most notably, the Charleston, Mattoon, Illinois tornado family of May 1917, and the Woodward, Oklahoma tornado family of April 1947.
A family makes it sound a little too friendly and happy.
That's a good point.
It's more like a tornado gang.
Yeah. Thieves and robbers. But so we go from there. So, Brandon, you talk about that. And of course, go ahead and continue about, again, the path length just does not fit scientifically. As far one tornado,
true.
right?
Yeah, that's true. A family of tornadoes, they're a hooliganizing again.
Yes, exactly.
In more recent years, we have had some very long track tornadoes and supercells that have indeed occurred, with 12 different tornadoes exceeding 100-mile path lengths from 1980 to 2012, and 60 of them since 1950. At the high-end estimates of the tri-state tornado path length, they are still far longer than the nearest verified very long track or VLT tornado. So no single factor can account for the exceptional path length and duration, though the fast forward motion of the tornado, which averaged 59 miles per hour and did hit speeds of 70 to 75 miles per hour, could have translated into greater distances covered than would a typical storm traveling at more typical speed.
Right, and that may have played a part in it. We do know the Woodward, Oklahoma tornado of 1947. It was several tornadoes in that grouping. The first couple tornadoes were The first one was relatively not much at all. The second one, in the parts of the eastern Texas Panhandle, I think it was an F2, and of course the cell recycled and then put down the monster tornado that ran through Woodward, killing all those people there in 1947. But again, several tornadoes, not just one specific tornado, was responsible for a lot of the damage. Of course, the Woodward tornado was the strongest of the group, and it blasted through there. But there were weaker tornadoes in front of Woodward, and then a couple after Woodward. So,
yeah, and the same is true of the more recent Quad State tornado, which now is pretty much identified as being a family.
Right. So,
I would almost like to see an experiment conducted, and I think you could do this in a computer model. Set up two tornadic storms, identical storms under identical atmospheric conditions, and make the only difference being the storm's forward momentum.
Right.
Have one of them going, 40 miles an hour, and one of them going 60 miles an hour, or even 70, and see if speed alone could account for a longer path.
I think that's a good point.
If the forward if you reach a point where the storm is moving so fast that the forward momentum and that air mass colliding with the rest of the atmosphere destabilizes things and starts to rip it apart.
Well, however tornadoes there were, they maintained their F5 strength through a good part of the path. And only at the very end, before it dissipated, did people see multiple funnels and saw the storm actually break up. But we now know that it did put down another tornado after that one broke up. We'll talk about that in a moment. But in 2001, our dear friend Tom and Mr. Tornado himself.
Yeah, Tom Krasoulis. He made an examination, of course, of this tornado, among other tornadoes, for his groundbreaking book of significant tornadoes. And he wrote at that time that the first 60 miles of the track was probably the result of two or more tornadoes, and that a 157-mile segment of the overall path length was seemingly continuous, which actually would have worked out pretty well with other well-known very long-track tornadoes. The trouble is that Doswell and his group looked at it, and they think that while there probably were some other tornadoes in there and bits of the track were something else,
right,
most of that track was one tornado.
It really was, yeah.
The 2013 study, which is the one that Doswell and his friends did, concluded with moderate confidence, and again, this is just moderate confidence, and that's probably about as good as we can get at this remove, unless some kind of new evidence comes to light, and I can't imagine what that would be at this point, that the 174-mile segment from central Madison County, Missouri, to Pike County, Indiana, was the result of one continuous tornado, and high confidence that the 151-mile segment from central Bollinger County, Missouri to western Pike County, Indiana, was the result of a single continuous tornado. The first value would hold the record for the longest recorded tornado track, but the latter would actually be beaten behind the 165-mile track of the Western Kentucky tornado, which occurred on December 10th, 2021, so actually quite recently. However, the 151 to 174 mile long figures for the path are considered most likely to be continuous because observations were sufficiently dense. That means people were watching this thing basically all the time. It went from one observer to another one, to another one, to another one. And also, and I don't think this is emphasized enough, even at the time, meteorologists did go back and go over the track. Now, there are several gaps because there's some of those areas were pretty sparsely populated, but even in those areas, it may well have still been a continuous track. It's a fascinating storm.
It really is. It really is. Now, some evidence for that would exist if you've ever seen video of the 1990 Heston, Kansas tornado.
Yeah, that was a big one.
Yeah, but when it started to die out, another strong tornado formed right next to it, and so the path is almost continuous. Yeah. And the tornado, it spawned after the one F5 was another F5, so it was which might be almost unique. Yeah, very unique. So it could give plausibility to the fact that the tornado could have the supercell wall clouds, mesocyclone could have restructured and dropped another strong tornado right as the other one was beginning to die, which might be a little less damage, and all of a sudden the damage picks up again. Again, that's speculation, but it does make sense that is after Heston, Kansas, that we see that it is very possible that could have happened. So, again, the continuous path. And Brandon, some closing thoughts on this part of it, which what we're seeing there is, the question still remains about that. So again, we take all that information and put it together and shake it up in a hat and realize that it was just more than just the incredible tornado on the ground, but a lot of weather ingredients came together to maintain this supercell for a very long time. Brandon, touch a little bit on that.
Well, we can definitely infer there had to have been some very good upper-level support, especially given that the tornado traveled at speeds of 60 to 70 miles per hour for most of its path. Now, because of that, we can safely assume that maybe a 100-knot upper-level jet max was nosing into that area from the west-southwest. Now, with veering winds south of the surface becoming west-southwest aloft, wind shear was also present to help initiate the storm's rotation. So I think there must have been some decent instability as well, with all that warm air advection at the surface and probably cold air advection at the upper levels. What makes this tornado interesting, though, is that its occurrence was nearly coincidental with the track of the surface low. Now, while other tornadoes in the warm sector of the low affected parts of mainly Tennessee and Kentucky that day, none were as massive, as long-lasting, or as violent as the tri-state tornado. This goes against the conventional thinking that while it is not uncommon for a tornado to occur in conjunction with the surface low, the most violent ones actually occur in the warm sector of the storm, well south and east of the low's track. So there's definitely a little bit of contradiction there.
Yeah, because of the fact that the information is sparse from that time, no matter how well you research it, you have those issues. But the fact is, again, the best thing you can say, there's a unique situation that let this storm propagate as long as it did in that sector where it was, because normally the stronger tornadoes would be further south in the warm sector, but this rode right along that triple point and basically stayed there for 3 hours. Again, unusual meteorological conditions that came together, but it does happen. So then it's left with the question, then what happened? What was the tri-state tornado? What do they think?
Yeah, exactly. It is such a unique and weird event that people, obviously 100 years on, we are still talking about it.
Yes.
Path of destruction really appeared. We did talk about the path earlier. It really appears to have been continuous. But the question is, and this actually is a good question, if the tri-state tornado was one massive, continuously occurring tornado, why hasn't such a storm been described since, or for that matter before? Of course, before, kind of hard to describe because there just weren't enough people around to see it. But there has been nothing quite like it since. Is it just that we lack enough information to come to a conclusion and say, well, this was a cyclic supercell, but it was kind of a weird one, or this was some kind of unique freak of nature that may never occur again, and that wouldn't necessarily be a bad thing, considering that this tornado killed almost 1,000 people.
Yeah.
And a tornado like this today, I think, would also cause a good number of casualties, even with modern warning systems.
Right. It would have been, it's no matter when this occurred, it would be an unsettling situation, a very damaging one. Maybe the loss of life would be less, but still the fact is the damage would be still just as massive and complete as it was, back then. So that's a basic overlook of what happened with the tri-state tornado. A unique set of circumstances weather-wise. It probably let it go as long as it did, as fast as it did, for 3.5 hours. There have been tornadoes that have had paths of 100 plus miles, and not been that many of them. But they've been very violent. I'm thinking of the one that hit Gwinn, Alabama, then went through that national forest. It's a 101-mile track. Yeah. And dissipated just before it hit Huntsville.
Yeah.
So you have that in line too, and you've got several tornadoes that have had very long tracks, over 50 miles. A few of them over 100 miles. They are very rare. And it always takes a unique set of circumstances weather-wise to get them together. So maybe it's a once in a 500-year tornado, once in a 100-year tornado, once in 250. Hard to say. But you just got to wonder, the one conclusion they do make, this could happen again.
Yeah, it could.
When or where, we don't know, but it could happen again. But again, a very strange situation, very sad one, because obviously all those people died. And the kicker to that is, you know what happened the next day? Snow.
Of course.
Snow. Cold and
Of
snow.
course.
Temperatures back in the 20s, and 4 to 6 inches of snow throughout the area. Again, you imagine trying to clean up for everything, and you're bone-chilling cold then on with wind chills and blowing snow. And
I mean, you're trying to find people, to either rescue them or bury them, and, animals everywhere, and, geez, it's just dreadful to think about.
It's very heartbreaking. And, go ahead.
I was going to say, I can't help but wonder on some of this. This tornado happened a century ago. Reporting, communication, media, and record keeping, although they did exist, they were not what they are today. There were no computers, there was no internet, there were no satellites, there was no social media. The only broadcast medium that was available was AM radio. And outside of that, your primary means, really your only means of, quote unquote, instant communications would have been the telephone and the telegraph.
Right.
So, and, yes, there were meteorologists back then. We're not talking about the Stone Age here. But their understanding of these kinds of things was not what our understanding is today.
Right.
And I remember, asking Angela this question when we had her on to discuss this. They didn't have the terminology. Maybe they didn't have the framework to understand these things that we have.
Right.
So I really can't help but wonder if, especially as there are no known photographs of this storm, there's certainly no film or video of it. We have only, eyewitness accounts and descriptions, which are unfortunately sometimes, less than 100% reliable.
Right.
Because there can be gaps in things that people saw, or, they may have simply not been able to articulate what they saw. I think there are still a lot of blanks. There are a lot of gaps in the information, and I can't help but wonder if this is something that we're never going to fully know what happened.
I don't think it's possible to fully know what happened.
Right, I agree.
At this point, we're at such a remove. The thing that's kind of sad to me is back in the day, all of those teeny tiny towns had their own newspapers.
Right.
And you have to wonder how many of those archives have been lost in the years since that would have had, information and eyewitness accounts.
Yeah. Very sad.
And Sue, you were talking about how many of these areas were so rural back then. It's something important to point out is, today the population of this country is right around 330 million, give or take a bit. In 1925, I believe it was well under 100 million, so less than a third of what we have today. And to your point, a lot of these areas would have been very rural and very undeveloped. And a lot of cities today were small towns back then. Some small towns today didn't exist back then. So it may have simply been that there weren't very many people who saw this thing from a vantage point that would let them really study it and try to understand and describe what they were seeing.
Yeah, and also, again, I think probably a lot of the accounts have just been lost because you don't just have accounts in, small town newspapers that may not have been preserved. You also had people, they would write letters and write diaries, and you don't know what people have in their attics, frankly.
Yeah, we've always speculated there may be someone may have a picture of the tornado in their attic. You never know.
And not know what it is.
And we also have to remember that, we talk about people seeing it up front or having an eyewitness. We have to remember many of the eyewitnesses that tornado died.
Yeah.
They saw it coming. When the time they figured out what it was too late. Because we take a look real quickly, again, what happened. It affected 3 states, Missouri, Illinois, and Indiana. That covered 13 counties. Not a lot, just 13 counties. That's
Those
how
are good sized counties.
Yeah, they were
though.
good size. Yeah. But it didn't affect, just big swaths of the state. Missouri, Illinois, and Indiana, 19 communities, including Ellington, Redford, Ladana, Annapolis, Cornwall, and Beale and Frona in Missouri, and of course Gorham, then Murfreesboro, which is the hardest hit town by the storm, DeSoto, Hurstbush, West Frankfort, and moving into Indiana, Griffin and Owensville. The path, again, 219 miles in length. The total path, that includes whether there's one or several tornadoes. Average width was about 3/4 of a mile, with some widths over a mile wide. And the supercell tornadoes that it produced, whether it was one or several, lasted 3.5 hours. So, again, it touched down at 1 o'clock in Missouri and dissipated near Petersburg, Indiana at 4:30 in the afternoon. So for 3.5 hours of terror in the middle of all that was just awful. And just a little note on this, we'll jump to the closing points in a moment. The lowest pressure measured on a barometer was at the Old Bank coal mine in West Frankfort, 28.87. That was a low as the storms passed. Now, that wasn't actually in the tornado, but probably as it passed, the barometric pressure dropped pretty significantly. So
that's the kind of low you'd normally see in a hurricane.
Yeah, we're getting into that. So, and that wraps up the first part of our looking back at the weather conditions that caused the tri-state tornado. On our next episode, we'll be talking about not only that tornado, but tornadoes that occurred that day also that took an additional 100 lives. So for Twister Talk, I'm Gary.
I'm Sue.
I'm Brandon.
And we'll be back with part 2 next time. Take care.